The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Welcome to the webinar. We're gonna wait a couple of more minutes to see how many can join for this webinar. It's such a big crowd. It's so nice to see that so many attended this GoToWebinar. I'll also start this webcam so you can see the person who is talking behind this microphone. Can everyone see my screen and my webcam? Hopefully everyone can see it. Make it smaller. All right, welcome everyone. Such a big number of attendees to this webinar in FEM-Design for modeling after AutoCAD drawings. My name is Flavio Popescu, and I am a sales and support engineer at Strusoft, Denmark. This is a GoToWebinar meeting, so I will host the webinar, and my colleague Dennis will be answering questions. Please, if you have questions, there is the questions section in the GoToWebinar menu. So just open that questions tab and write your questions. Okay, I think we should start. Modeling from AutoCAD drawings in FEM-Design. Let's start with opening an AutoCAD file, an AutoCAD drawing in FEM-Design. So I have FEM-Design 3D structure. I go to Edit, External Reference, and I choose a file path for my AutoCAD drawing. I go to where I have it saved, and I just select which AutoCAD file I want to open. I have it saved here, so I know I opened the one that I want. And I go back to FEM-Design, and I have to enter a external reference first. So a first point of origin. I'll just put 0.0. Then I'm asked to define a second point, or the direction of X, the X direction. So in FEM-Design, I have green for X, yellow for Y, and blue for Z. So I'll just put it on the X-axis. And now I have to enter a third point. So I make sure that I align my axis with the coordinate system in FEM-Design. And I click, and I get this AutoCAD import menu. Here I have the layers in AutoCAD that I am going to import. I just select all of them for now, and I click OK.
Can you move the microphone a little bit?
I will just mute my colleague Dennis. So we will get a good sound. All right, great. Let's continue. So I have my AutoCAD drawing in FEM-Design. What I want ideally when I draw from FEM-Design, when I draw from AutoCAD, when I use an AutoCAD drawing and I want to model in FEM-Design, ideally I want to make sure that I have only the lines that I need. This will make it a much easier task for me to model a proper and good FEM-Design structure. So any other lines that I will not use, it's best that I eliminate them from my AutoCAD file, from my AutoCAD drawing in AutoCAD. For now, I'll just use this and show you how to model on this one. So I have a drawing from AutoCAD imported, and I have this floor plan, and I want to make a plate. Let's say I want to make a plate. I go to Plane Plate, and I want to draw it according to my AutoCAD lines. If I go to Plate, the Plate menu, I select Pick Lines. So I select my lines, make sure that I select the proper line that I want. So I'll continue with this. And I have a plate. This plate is drawn to the lines that I wanted, this contour here. And I go to my wall menu, I go to Plane Wall, and I can either draw my walls with a straight line. Let's say I want to draw this wall here. And if I want to see what I draw, since this is a 3D model, I'll go to my 3D view. Again, I want to make sure that I draw according to my AutoCAD file, but I also want to make sure, most important thing, is that I snap to my FEM-Design model, to my structure in AutoCAD. In FEM-Design, to my structure in FEM-Design. I want to make sure that I snap my objects in FEM-Design. So I just drew this wall according to this line. If I want to do it like this, I can also select this line by selection. So I'm going to make this curved wall here. If I just right click on my line, the wall is drawn. I can see that I have a curved line here. So my walls will be drawn as in plane surfaces. So it will be divided into these several sheets of wall. This is how FEM-Design will draw it. What is a good rule of thumb to to have when drawing from AutoCAD. Every time I have a new element that I have drawn and I want to make sure that it is connected, I can use the finite elements mesh. Let me turn off the AutoCAD file for now and look at my structure. This is the structure that I have now with my plate and my walls. A good thing is to use this generate finite element. I can see that there is a warning, unexecutable local refine of finite element mesh. This gives me an idea that it probably is a geometrical error. If I try to zoom in a little bit, I can see that if I go to structure, I probably have a better view and go to layers, turn off my AutoCAD file so I can better see what's going on. I can see that my plate and my walls are not properly connected. This is very good to detect early on. If you start having, if you are planning to make a big model, a large model in FEM-Design, having these geometrical issues found early will be a great help. Starting and making sure that everything is precise from the beginning is the first step to a successful model. So I can use this finite element tool, this generate tool, to make sure that I have a proper connection between elements. Right now, I can see that I have these small surfaces outside of my model. I don't want that. In this case, maybe it's a good idea to have the walls first, since I see that they are not a curved line. So if I have my walls first and maybe I draw my plate afterwards, it will be better. In a lot of cases, it's good to draw your elements from the beginning. Delete the ones that don't work and draw them again. That is a good way to make sure that you are precise from the beginning. I will turn on my layer, my AutoCAD layer again, and I'm going to draw my plate again. This time properly aligned to my FEM-Design structure. So if I go to plate, I'm going to use the polygonal tool. I am going to start and draw it from here, from this corner, and connect it to this wall. And again, I want to make sure that I connect and snap to my FEM-Design model and not to my AutoCAD model. So I make sure that I have a proper connection. I have in layers, if I go back to layers, I have this no snap function. If I select the layer, my AutoCAD layer, and I select no snap, I will not be able to snap on my AutoCAD drawing. I'll make sure that I will snap according to my FEM-Design structure. I will start snapping to my structure. And this time I will make sure that I connect to the walls. So I just follow the line of my walls. Making sure that I have a proper connection there. I will continue making my plate, and I want to go back to snapping to my AutoCAD file. So I remove the no snap, and I just continue drawing like that, snapping to my AutoCAD file for now. I can see here that I have a another curved corner. So I will proceed. I will continue doing like I have here. I will draw my walls first. And then proceed with drawing my plate. I have to start over again since I did not draw the walls from the beginning. All right, so I want to draw my plate now. Again, I want to make sure that I don't snap to my AutoCAD file, and I snap to my FEM-Design model. It's good to do it, make sure that, and like switch back and forth. That's a good idea to do it. So I make sure I get a good model and a good connection. So now I snap to my FEM-Design model. Now I want to go back and snap to my drawing. So I deactivate the no snap in my layers. And I have my plate. Again, I check with my finite elements by generating a mesh. Just select my elements. And now I see I don't have a warning. So this is good. I have a proper connection between my plate and my walls, and my mesh looks good. So it's a good idea to do this meshing of your current drawings. Of what you've modeled already, just generate a mesh for those elements, and make sure that you have a proper connection and a proper mesh. So I can, then I can just activate my AutoCAD file and then continue drawing. This is a good I guess schedule to follow, like drawing and then meshing to check if it's a proper connection. If you have questions, please type them in here in the GoToWebinar menu and under questions. I want to show a different, another model, and maybe take a look again at this, how this mesh tool can be used, and how it's useful to detect maybe geometrical errors in my FEM-Design model. I have here a structure, and I can see that I have a very dense mesh. this tells me there's probably something wrong here in my edge connection here. I have some walls and I have some plates. And this dense mesh shows me that there's something wrong probably. I go to structure, and if I zoom in really closely, I can actually see that there's a misalignment here. I can also turn my plates off from layers, and I can see that there's a misalignment. This can happen pretty often, and it's pretty common mistake or geometrical issue that can happen when drawing to AutoCAD. Also, the AutoCAD drawing could not be exact, may not be exact. So when drawing in FEM-Design, of course, you get a misalignment like here. Or maybe the modeling was not precise enough. So I snapped to a different line that I didn't want to. Also, again, a good idea to use only the lines you have, only the lines you want to use from AutoCAD. Also, when you start drawing from plane, you start with a plane drawing, and then you start building up from it. I drew my plate, I drew my walls. Now, if I want to make another level, I would just ignore this AutoCAD file. Also, if you turn off snap, then it won't be you won't snap to it. But I can also start drawing from my current structure. So I can start using this as a point of reference instead of my AutoCAD file. Of course, whatever works best for you. But I wanted to show you this example here, how you can detect these misalignments, small geometrical issues. Let's take a look at another example. I have a concrete plate here. I have a plate drawn, and a common error message that I get when I perform my analysis is overlapping. When drawing from AutoCAD, it can happen. It's pretty common that I draw elements, two overlapping elements. I draw two elements at the same time, at the same place, or I draw elements that are overlapping. Sometimes it's hard to find this where this overlapping issue happens. Again, I can have this finite element tool, which will help me identify. I'll show you how it works. If I go to finite elements, I go to generate, and I generate a mesh for my structure. In this case, this plate. I get this error. This region exactly overlaps another one. And I can see that hatched, that highlighted surface is the surface that gives me this problem. It says exactly overlaps another one. That probably means that I've drawn it several times, or it's drawn on top of each other. A good way to deal with that is to go to structure and erase this region. Again, it's hard to tell how many times I have created this plate and how many overlappings are happening. So I just delete this surface. I just click on it with the delete until it completely disappears. And if I undo it once, pressing Control Z, or there's also one undo here, I make sure that I have one surface drawn there. I make sure that there is no double or exactly overlapping on top of each other. So if I go to finite elements again, go to generate, if I select my plate, this time I get a different error message, a slightly different one. I don't get exactly overlapping. I get these two regions partly overlap each other. So I can see that this big region overlaps with this smaller one. So I can see that there is an error there. Now, if I zoom in really close, I can see that these two regions overlap each other. So what I do is delete probably the smallest one, and then make sure I connect it properly, or of course, start drawing my structure again. Start and making sure that everything connects and everything is precise. Let me check my GoToWebinar window. Okay, so I have some. Please enter your questions in the question section here if you have any. And hopefully my colleague Dennis will be able to answer them, all of them. I'll just put it there. So this is a good tool to use when modeling from AutoCAD to FEM-Design. I can also have, it is possible also to have a 3D drawing from AutoCAD imported into FEM-Design. So if I have this example here. It's a very nice structure, very detailed structure with some staircases, some stairs, some stair steps, and the supporting structure. And we helped model this. We imported this file from AutoCAD into FEM-Design, and we had this model here from it. We the staircases, the stair steps were modeled as shell elements. So I can see that I have my steps here, and these were created as shell elements for the different elements here. And those elements, those shell elements were connected to this supporting structure, which was some beams and columns, which were drawn as bar elements. It was a very nice model, and we could get the stresses in the shell elements, and we could also get the deformations in the structure. But regarding AutoCAD, I want to make sure that I use the right lines when I draw. So really often I have this AutoCAD, which is 2D, and I have maybe some thickness in here, some some thickness in my AutoCAD drawing, and I want to make sure that when I draw my plate, I draw it properly and connected to all of the other elements. Ideally, I want to have, again, as I said before, I want to have one line. So instead of having these double lines and representing my thicknesses, I want to have only one so I can easily draw my plate. But this was it's possible to do this too. Have a 3D AutoCAD file and import it into FEM-Design. These were the examples that I wanted to show you. And a good way of modeling correctly or precisely from AutoCAD to FEM-Design. I can see that there are some questions. I will just check with my colleague Dennis. these were the examples that I wanted to show. I will leave this webinar open and open the microphone for Dennis as well, so he can also answer some questions through the microphone. Okay, so Dennis can use the microphone now as well.
All right. Thanks, Flavio. I'll go through the questions on this on the microphone instead of writing, because I cannot follow the pace here. There's a question here from Carl. Merge objects distance, how does that impact the meshing? Honestly, I'm not sure about this. I'll have to investigate it. I always recommend that this merge object is not used because it's difficult to control. How it's adjusted, the new function in 17 will be much, much better. So normally I tell people don't use this auto merge. Just if you have mesh problems, go in and have a look and adjust the model manually so you know the model is correct. Then we have a question from Gamal Eldin. What if no errors were detected after meshing my structure, but my analysis results show high displacement? This is if you have if you have not connected your elements, you have no overlapping, and you will not get any warning from your mesh. It could be this could be what you wanted, to have a distance so they don't transfer forces. This is difficult to detect, and as you write, you need to take a look at the displacement figure to find these things. So again, I will just say that just focus on modeling your structure exact, so you're sure everything is connected. Especially pay attention to this no snap function you have in FEM-Design, so you don't snap, because in AutoCAD you can have several lines with just 0.1 millimeter in between them. And if you just snap to a different one of them, you cannot control which one you select, and you will have small displacements. And FEM-Design is very fragile to these small displacements. So just make an effort out of making the model correct. Matthias is asking, I was thinking about your last example. There's eccentricity in the center points of your beam elements in the drawing, but in FEM-Design they are connected. What we did in this model, the only thing we really modeled from the CAD drawing is all the steps and the plateaus. So the columns are just connected upon the model afterwards. So they're not, the columns are just drawn as bar elements, not as shell elements. So we just model that after the geometry afterwards without snapping to the lines on the CAD drawing. Ideal mesh size, that's a good question. The best way you can do this is to see when your results converge. Normally, I would say that the mesh FEM-Design gives is normally a very good first guess. But if you want to be sure, you need to look at your internal forces and just decrease your mesh size, increase the number of finite elements, and see if the values converge, go through a specific value if it changes a lot. So it's, I would say in steel, if you have joints, I would go much smaller mesh. If in concrete, I would go a rougher mesh. So in concrete, I might select, if it's a big slab, 0.8 meter. You will have 9 nodes in that area. 0.8 multiplied by 0.8 or 1 multiplied by 1. If you calculate prefabricated elements, you're not so interested in these small details, so you might go bigger mesh. So it depends if you want to use FEM-Design to design your reinforcement, or you just need the external forces. So it's very individual. where can I define the connections between different elements? The connections between different elements. Do you mean the edge connections between the plates? Mara, you can just get back to me on this. So the bar elements were not imported. You drew them by hand in FEM-Design. Yes, Matthias, that is correct. That is correct. And then Jakob, if a HIB beam lower flange is lying on another HEV beam upper flange, how would you make the connection? I'll always make a distance in between them, and then I would go, if you are welded it together, I'll go with a line-line connection to actually model the welding. If you're bolting it together, I would go a point-point connection from the upper flange to the bottom flange on the above lying HEB profiles. When you do a point-point connection, you need to consider the peaks. So normally what I do is I peak smooth the dimension of the, what is it called? The not the bolt, but the plate on the bolt, because I found that reasonable. But this is something you need to consider, and then you can get out all your forces, export it to Excel, and test it in your bolt software. Mara, when you connect the different members, you have I normally always use this line-line connection and point-point connection, because then it's easier to see what forces goes through the connection. If you model something to intersect, it's more difficult to see what forces actually go through it. Of course, if you have like a normal building with slabs and walls, you don't do it like this. You do just edge connections, and you change one of the values away from the rigid, and you see your edge connection results. That's the same. So an edge connection result works the same way. It's just a finite element member in between the plate and the wall. If you have specific questions or examples, you are more than welcome just to draw it on a piece of paper, scan it, and send it to us on an email. It can be difficult to understand completely what you mean without a drawing. So just do that and send it to our support email address, and we will get back to you. Do you have any more questions? And Igor, he tells me that he was able to make the lines thinner in FEM-Design 15, but in version 16, there's a problem with that. We will have to test that. I did not know that, but we will test that. And if it's a bug, we will fix it. Are there any more questions for now? If you have any questions, there was one more here. Could you repeat the process from importing AutoCAD drawing to FEM, because we missed that part. As many of you know, we always upload the webinars on our YouTube channel. So go in and you can see the complete webinar afterwards. Basically, there are two ways. One way is to use the external reference, where you can update from your CAD drawing when changes have been made. That's where Flavio shows you right now, the external reference. You just point to your file and you give an inset coordinate to your drawing. Another way is just to go up to File and click Open and select the file type DWG or DXF and point on it, and then you can open it. But remember, it's when you do this, it's just lines. It's not an intelligent 3D model. It's just lines in 3D. So you can use it for snapping. Okay. If you have any further questions after this webinar, I'll just write our support email address that we all look at. It's called support.femdesign@strusoft.com. So like this. So feel free to write us your questions. All right. Thank you very much and have a nice day.
Thank you very much, everyone, for attending. To those of you who are already using FEM-Design, I wish you happy modeling. And to those of you who don't use it anymore, don't use it yet, you can apply for a trial at strusoft.com. Under Products, FEM-Design, and get a free trial version. Once again, thank you for attending, and have a nice day.